Here we have a pre-calculus problem. Okay, let's go to the question. Prove log a square over bc positive, log b square over ca positive, log c square over ab equals to 0. Okay, here on the left side we have logarithmic expression and we have to prove the value of this logarithmic expression is 0 that we have on the right side. Okay, now let me take this stuff on the left side as it is. It is the log a square over bc positive, log b square over ca positive, log c square over ab. Okay, here on the left side of the equation we have addition of three logarithms, and for each logarithm the base is not mentioned. For any logarithm, if the base is not mentioned, we have to assume it's a common logarithm. That is the base of the common logarithm is 10. That is we can write 10 if I want, but we don't have to mention. We can assume the base for each of these three logarithms is 10. That is a common logarithmic base. Okay, now let me consider the product rule of logarithm, that is log base a of m positive log base a of n. Okay, here add two logarithms at the same base. Whenever I add two or more logarithms at the same base, what I have to do is I have to take logarithm once with whatever base we have for the two logarithms, and I have to multiply the arguments m and n, then I'm getting m times n. So this is a product rule of logarithm. Now I can use the product rule of logarithm for the addition of three logarithms we have over here, because the base for each logarithm is assumed as 10. That is, the base is same for all the three logarithms. Now we can take logarithm once for all the three logarithms, and we have to multiply the arguments of the three logarithms. That is a square over bc times b square over ca times c square over ab. Okay, here log, we can multiply the numerators. So whenever we multiply two or more fractions, we have to multiply the numerators and denominators. When I multiply the three numerators, I am getting a square times b square times c square. Now let's multiply the denominators. When I consider the denominators we have over here we have a, here we have a. When I multiply this a and a, I am getting a square. When I multiply this b over here and b over here, I am getting b square. And when I multiply the c over here and c over here, I am getting c square. Okay, here in this fraction, the numerator and denominator are same. So in a fraction, if the numerator and denominator are same, the value of such fraction is just 1. And in any logarithm, if the argument is 1, then the value of such logarithm is 0. Okay, here I have proved that the value of this logarithmic expression is equal to 0.